Alright guys, welcome back. Today we're going to talk more about proving congruence. I'm going to give you 4 questions. We're going to start from the easier questions, and the last one is going to be a little bit hard. Okay, so let's get going. First of all, you have your Kn bisecting Jm. That means you will cut the Jm into 2 equal pieces. And then we have Jk parallel to Mn. You can see that angle J, for example, is going to be exactly the same as angle M because of the zigzag alternating angles. On the other hand, we also have K equal to N. So I think we get all the information that we need. Now, first of all, you will say LKJ equals to LNM. Well, this is because of the alternate angles. And second of all, you will have the other way around. LJK equals to LMN. Now, you probably realize, guys, that you can actually just write angle K, angle N, angle J, angle M. That's fine as well. And the reason is also alternate. Lastly, you actually have this JL equals to ML. And the reason behind that is because of the bisector KN. Finally, you can conclude that triangle JKL is congruent to triangle MNL AAS. So that's the end of the proof. Moving on to the second question, we are given a few informations over here. First of all, FA is perpendicular with AD. Okay, mark it up. ED is also perpendicular with AD. Here. And then next you have this weird equality over here. They tell you that they're not telling you AB is equal to CD. They're actually telling you AC being equal to BD. Okay, so it looks something like that. And then you have your angle F, same as angle E. First of all, we have AC equals to DB. Okay, this is given, but that's actually not exactly what we want. So we need to do a little bit of manipulation over here. AC and DB are the same. So that means if I take out this same guy over here, BC, if I minus BC on both sides, we will still be exactly the same. Okay? And after the subtraction, you're going to have AB equals to BC. That's what we want. Moving on, we have our angle A equals to angle D equals to 90 degrees. Okay, this is given. Or you can write perpendicular if you want. Next, we have angle F equals to angle E. This is also given. So finally, we can conclude that triangle ABF is congruent to triangle DCE AAS. Now, you probably realize one thing. Just because I have 90 degree doesn't necessarily mean that I'm going to have RHS, okay? In this case, I have 90 degree over here, but I'm actually really having an angle, and then a side over here. And this side over here is not right in between the angle. That's why we don't call it ASA. We call it AAS. So that's for this question. Moving on to question number 3, we have a bunch of information over here. Let's walk through them together. First of all, we have PQ bisecting YZ. Okay, we can mark it up like that. That basically means your PQ cuts your YZ into 2 equal pieces. Second of all, you have Q being the midpoint of WX. That means you will cut the WX into 2 pieces as well. And next you have angle Y equals to angle Z. Angle Y is equal to angle Z, like this. And lastly, you have WZ equals to XY. Here's your WZ, here's your XY. We are going to prove angle WQP is equal to angle XQP. Okay, so that's what we're going to prove right here. Okay, these 2 crosses are to be proven to be the same. First of all, we have ZP equals to YP. Okay, and the reason behind that is bisector PQ. Second of all, we have WZ equals to XY. This is given. Now third, we have angle Y equals to angle Z. This is also given. So with that, we can actually prove the fact that triangle PZW being equivalent to triangle PYX. Okay, this is SAS equivalence, congruence over here. So we're basically saying that these 2 triangles are exactly the same size and same shape. That means you can say anything about it, including these 2 sides being exactly the same. Okay, so you can say how PW is equal to PX. And the reason behind that is congruence. And next, we have WQ equals to XQ. This is because of the midpoint. And lastly, you have this PQ equals to PQ. Well, because this PQ is shared between the 2 big triangles in the middle. And finally, we're done. We are saying that triangle WQP is actually exactly the same in terms of size and shape with XQP. And it's because of SSX over here. And just because of that, we can finally conclude that angle WQP is exactly the same as angle XQP. Okay, again, this is because of congruence. Okay, so take a look. Now let's take a look at this last question over here. This is one of the exercise problems on page 137, question number 9. We're actually given ABCD as a rectangle with equilateral triangles being drawn from each side of the rectangle with apexes W, X, Y, and Z. We need to show that W, X, Y, Z is actually a rhombus. Now, first of all, what is a rhombus? Okay, what defines a rhombus? A rhombus is basically a quadrilateral with all four sides being exactly the same. Okay, so as long as you can prove that quadrilateral has four sides being exactly the same, we can show that, we can conclude that this shape is a rhombus. Okay, so first of all, let's connect all four sides together. Okay, so with that being drawn, let's go ahead and mark up the triangles over here. Because they're all equilateral triangles, here's what we can do. We can mark all these up over here like that. Okay, pay attention because we have rectangles. For example, BA is different to BC over here, so that's why we use two different, dash lines styles to show that they're actually different in terms of length. Okay, so after that, I think we can get going. Now, the first thing that I want to do is actually prove that these four triangles over here are actually all congruent to each other. First of all, as you take a closer look into each of the four triangles over here, you'll realize that I already have the sides, the two of the sides being the same already. If you compare amongst all these four triangles, we already have two sides. For example, XB and WB is the same as XC and CY, respectively. Okay, there's only one thing that we're missing over here, which is the angle. Okay, if we can prove that, for example, this angle XBW is the same as XCY over here, then we're done. Because basically we're proving SAS congruence over here. Okay, so we're gonna do this. We say XBW angle is equal to 360 degrees minus 60 degrees minus 60 degrees minus 90 degrees. This is equal to 150 degrees. Okay, but then similarly, we also have ZAW equals to ZDY equals to XCY equals to 150 degrees. Okay, so that basically means all these four angles are the same. Okay, now we have XB equals to AZ equals to DZ equals to XC. Okay, the reason is because we have small equilateral triangles. Okay, it's because of the small equilateral triangles, we have all these sides exactly the same. Okay, the next thing is we have AW equals to DY equals to CY equals to BW. And the reason behind that is because of the big equilateral triangles. Now with all that, we can finally say that triangle XBW is congruent to triangle ZAW and blah blah blah. And we have SAS congruence. That's why you can finally say that XW is equal to WZ is equal to ZY is equal to XY because of the congruence. Okay, so basically what we're saying is that these four are now all the same. And finally, we can conclude that W, X, Y, Z is a rhombus. So that's it for today, guys. You'll be able to find an e-copy of the worksheet on Power School Learning. That's it for today. Stay safe, stay healthy. I'll see you in the next lesson. Peace.